Okay, this is topic 210. Check your understanding. I'm going to go ahead and do the cosecant plus the secant of x. So number one, I'm going to do it on this piece of paper though. All right, so here we go. So f prime of theta, we discovered in class today that the derivative of cosecant is negative cosecant theta times cotangent theta. And then the derivative of secant was secant theta times tangent theta. Now, I am done, and I don't know what I could do to simplify it. I can look at it, but this is the answer, right? And so to simplify it, I would kind of go backwards through my problems and kind of take it back. And so I don't know if that's actually helpful. The denominators on these are all different. Nah, I'm going to leave it. This seems good enough to me. So, number 2. It just says find the derivative. So I'm just going to keep it simple. Number 2, w of t equals 1 over secant t minus 2 over 3 cosecant t. So to do this one, I'm going to actually start by rewriting it, not taking the derivative yet. So I'm going to stay with w of t for a minute. And secant is 1 over cosine, which means 1 over secant is cosine, which is easier to do calculus with, minus 2/3 cosecant is sine. 1 over cosecant is sine. So I have this. Way easier to take the derivative of. So w prime of t equals derivative of cosine is negative sine minus 2/3. Derivative of sine is cosine. I'm going to call that done. Seems good enough to me. All right, then number 3. Says f of y equals sine of y over tangent y cosecant y. Okay, so I'm going to see what I can do about rewriting this sucker too. So I'm here, I've got this. Okay, and so sine I'm going to leave alone. Tangent is sine over cosine. So since tangent's in the bottom, so 1 over tangent is cosine over sine, because I reciprocate it. So I've got cosine y times sine y, and cosecant is sine. Over sine. Those cancel out, and I'm left with cosine y times sine y. And I'm actually going to check this one a little bit funky, but I'm going to do that. Cosine times sine. Okay, so I've rewrote the tangent, cosine over sine, so cosine over sine. Cosecant is 1 over sine, so that means the reciprocal of that is sine in the numerator. Okay. So in other words, tangent y, cosecant y, I kind of did this. So cosine over tangent of y. So let me just looking at the bottom for a minute because it's a little weird what I did there. Is cosine, sine over cosine times 1 over sine, and the sines cancel out. And so this is equal to 1 over cosine. And so the denominator is 1 over cosine. And so it's sine times cosine. Okay, I feel more confident about that. It seems a better explanation. So now I'm going to take the derivative of, so f prime of y. So I'm going to use product rule, cosine. So the first times the derivative of the second. My brain's jumping the gun. Plus the second times the derivative of the first. And so I have cosine squared y plus minus sine squared y, which is too bad. I was hoping for 1. And so really fast, I'm going to look at, but this, I know that cosine and sine, when I subtract them, is something too. I just don't necessarily remember it. Again, this is the right answer. This is good enough. I'm just going to quickly check something. Trig Identities. That list looks really good. I'm looking for sine squared, cosine squared. Ah, right there. See right here? Cosine of 2 theta is cosine squared minus sine squared, and that's what I had. And so this is equal to cosine of 2 theta, 2y. So now, this is good. This is good. Not rewriting in the first place is fine. It would have been much harder, by the way, to not rewrite this. Highly recommend rewriting if you can. But eventually that is the right answer. And I'm sure that's what a multiple choice question would say. Although double angle identities, I'm not so sure. All right, so then number 4. Which is cosine times tangent, so 4 p of x is cosine x times tangent x, and tangent wow, it's just blurry. So p of x equals cosine x times tangent, which is sine over cosine. So that just makes it sine. And so p of x is equal to cosine, p prime of x is equal to cosine x. Let's just double check and do this the hard way. So using the product rule, first times the derivative of the second, excuse me, not 1. Secant squared or 1 over secant squared? Okay, secant squared, I don't know why I was doing that. Plus the second times the derivative of the first. Okay, playing games. Let's give myself some more room. That's a little tight. So I end up with 1 over cosine from this part plus sine squared x over cosine x. They have the same denominator, so 1 plus first derivative of second, second derivative of first. Actually, it seems very unlikely that I'm going to get back to cosine here. So I feel very frustrated right now. I'm going to go to my friend. Decimals. And I'm going to type P of x equals cosine x times tangent x. Huh. Weird. Okay. Look, that picture is sine. So P prime of x, there it is, cosine. And let's just type this mess I have, which is 1 plus sine of x. And to do squared on here, you can't type sine squared. It doesn't work. Just raise it to a power outside like that. Okay. Divided by cosine. Okay, I did not get the right thing. Something's wrong with my derivative. Because I trust what happened here first. So I'll think about that. Give me a second. Okay, I was looking over my work and I found it. So going back here. First times root of the second plus second times root of the first, I had positive sign. And so it's supposed to be negative, which makes this negative, which makes this minus, and 1 minus the sine squared of x. Since we know that sine squared x plus cosine squared x equals 1, 1 take away sine x squared equals cosine squared x. So this becomes cosine squared x over cosine, which is equal to cosine. No squared, because one of them cancels out. Okay, so I got the same answer. Let's just really quickly type this in instead of the plus sign that we had. Ta-da. Okay. So again, simplifying first, huge. Look how much, I mean, seriously, I went from complicated to straightforward and simple. Okay, so please simplify first. All right, let's keep going. Number 5.